Welcome back to Young Engineers of Today. I've only got a couple of people in right now, but I hope you guys had a good weekend. And, hope you're ready to go because we're going to continue with some more Arduino. Now, today is going to be a little bit different. We're going to focus on inputs instead of outputs. Last lesson, we did a lot of outputs, so if I go to circuits.io, we ended up making, I think this is it. We'll see once it loads. Yeah, we ended up making this circuit, which I thought was a pretty fun circuit to be able to utilize the power of loops in order to save ourselves a fair amount of programming. But that was the main focus of that, was to introduce you guys to loops and also to building circuits that were a bit more complex. So we had this nice LED light show that went on. But that was what we've done over the last couple of weeks, and it's been entirely output focused. But that's not all a microcontroller is good for. You notice if we look into our code here, we've always set pin mode to be output, which presumably means that it can also be set to input. So we can have any of these digital pins right here that we've used from 2 through 9 to be an input pin. Now, it can't switch between the two. It can't start out as an input pin and become an output pin throughout the program. It can only be set up as an input or an output pin once and then used that way. And that's just kind of for safety reasons. I mean, you don't really want to send information out on something if you have it set as input, because the electricity is probably really only meant to go one way. But that is what we've been focusing on, and it is possible to set it up so that it can be input. So I'm going to let it sit on this light show a little while longer. Now, who remembers like the 3 important parts to a for loop? Just as a means of review. Okay, well, let's put it this way. If I were to create a for loop that looks like this, how many times is that for loop going to run? Close. Very, very close. Yep, 10 times. Because this is going to start at 0, remember? So we're counting from 0, which means that we had an extra loop onto this for loop. So when we stop before we hit 10, that's so we don't run it 11 times, actually. And that can be kind of the wonky thing about getting used to a loop. Now, the reason why we start at 0 is, remember our code here, where we utilize I. So I is used each time throughout our loop. And you can use a loop in order to run through an array, which is sort of like a collection of variables. You can use a loop to run through lists and nodes and stuff like that. And the way a computer starts counting is at 0. 0 is the first value in an array, or in a list a lot of times. So, or in a string. So you want to start at the first value. So it's become sort of tradition to start a loop at 0 for that reason, even when you're not iterating through an array, to make it readable, or more readable, for a programmer, like in their programming mindset. How about that? How many times is that loop going to run? Not quite. So we did something a little bit different here. Now, instead of adding 1 to I each time, we're adding 2 to I. Well, okay, so let's look at it like this. So the first time the loop runs, I is going to be 0, right? Then the loop finishes running, and then we add 2 to it. So I becomes 2. The loop runs again, finishes running the loop. It adds 2 to I, so it becomes 4. And then 6, and then 8. And then it becomes time to run it one more time, except I is 10. Yeah, so it only runs 5 times because it doesn't run that last time. So we've essentially cut the number of times this loop is going to run in half by adding 2 to I instead of just 1. Now how about last one, I promise. Well, no, not the last one. Not the last one. I'm going to do another one. 5. How many times is that going to run? Yeah, I think, yeah, you should be right. So let's see here. 10, 9, 8, 7, 6, 5 doesn't run that time. So it still only runs 5 times. But yeah, at least 5. That would definitely, yep. Now, this one's always fun. How many times is that going to run? 0 times. How about this? Yeah, forever. So the first time I did it, when it was like this, it would run 0 times because it's not greater than 5. So it would skip the loop entirely. And then when I did this, the loop runs as long as it's less than 5. However, it starts out less than 5, and then the number keeps getting 1 subtracted from it. So it becomes -1, then -2, then -3. So it's always going to be less than 5, which ostensibly means it's going to run forever. It won't, strictly speaking, run forever because variable weirdnesses and computers and stuff like that. But um, as far as we're concerned, it'll feel like it'll run forever. And it'll do some really weird stuff. So that's those are a couple of things you need to watch out for with loops and stuff like that. Is you want to make sure that your logic and your math is set up right when you set up a loop. Otherwise, you could run into things where the loop never runs, or it runs forever, or it runs twice as many times as you want it to, or it runs half the times you want it to. So that's just something to keep in mind when you're messing around with for loops. So for us down here, we start at 2 and we go until we're less than 10, so we have it run 8 times because that's what we want. We want it to run 8 times because we have 8 LEDs. Same thing down here. Start at 2 until less than 10. Add 1 each time, runs 8 times. And by running through these loops, that's how we get the LEDs to blink in succession, because it starts at 2, turns on, waits half a second, turns off. At the same time, it hits the bottom of the loop, comes back up to the top, and it turns the next one on. So as you can see, as the previous one is still dimming, the next one turns on. And this is very pronounced when you go from the top LED back down to the bottom LED, because you'll see both of them be lit up for just a split second. And the reason why it's doing that is because this for loop is embedded within a larger loop that runs forever. So once we finish running this loop, we hit the last line of void loop. It goes back up to the top, and it goes right back into the for loop all over again. Normally, your for loops wouldn't be doing this. It's just we've got a for loop embedded inside of a larger loop that runs forever. So this for loop is constantly looping. We're constantly looping the loop. EODog, I heard you liked loops. Anyway. So I put a loop in your loop. Well, you can loop your loop. Let's go ahead and let's start up a new circuit. Oh wow, that is a special thing that happens when I drag that. Whoops. So I'm in my electronics lab. Make sure you navigate to the electronics lab through the Create tab if you're still on the home page of circuits.io. And once you're in the electronics lab, go ahead and click New Electronics Lab. And we're just going to leave it there for now and start talking about what we're going to do today. So today is going to be about analog read, serial print, and digital read. Well, we're at least going to explain analog read. We might only be able to do digital read because of 123D circuits, but yeah, we'll see. So who here remembers the difference between analog and digital? Also, am I yelling into my mic? Because I want to make sure I'm not yelling at you guys. Okay, good. How about the difference between analog and digital? Let's put it this way. How many values can you output on a digital circuit? Well, 2, right? And on and an off. Those are your only values for digital. You can either have full on or full off, 1 or 0. How about analog? How many values can you output? An infinite number of values. You can put out anywhere from 0 to full power and all of the values in between. So if your full power is 5 volts, you can send out 5 volts. You can send out 0 volts. You can send out 2.5 volts, 2.55 volts, 2.6 volts, 2.65 volts, 2.7 volts, 2.75 volts, 2.751 volts, 2.7501 volts. You get the idea. Any value between 0 and full power, including 0 and full power, you can send out on analog. So analog is like the dimmer switch for a light as opposed to just the on-off switch for a light that digital would be. So for analog read is all about reading values anywhere between 0 and full power, including 0 and full power. So we can get a much greater range of values with analog read. Now, if we wanted to use analog read, what might we use that with? Like, what would you maybe want to use analog read for? Just hazard a guess. Okay, well, maybe you might want to use analog read for something like temperature or the amount of light that a circuit is getting, or I don't know, the amount of force that something's receiving. Like if somebody can press against a plate or something like that, and then the Arduino can read it. So like a scale. maybe, I don't know, the amount of humidity in the air, stuff like that. Something that has a fine range, a wide range of values that that have, you know, fine sort of values in between. So it could be, you could be reading 75 degrees. You could be reading 74 degrees. You could be reading 50 degrees. You could be reading 65.3 degrees, that sort of thing. That might be something you want an analog read for. You could be reading full light, no light, a little bit of light, a fair amount of light, quite a lot of light, but not full light, that sort of thing. You might want analog read. You can measure light with a photocell, which is also called, yeah, exactly, pi light, which is also known as a light-dependent resistor. And its resistance decreases as its light source increases. So basically, the more light there is on an LDR, the more power it's going to let through, the less it's going to resist. So that's one way you can measure light using just electrical components, which I think is pretty cool, the fact that there is a resistor that exists that becomes less resistant the more light there is on it. Now, I don't think we're going to be able to do an analog read for this because we can't really simulate the amount of light in circuits.io. So we'll go ahead and skip that one. We are going to go over the serial print aspect of this, though, because that is something that I want to go over. That is something that you can use with circuits.io regardless of whether or not you have the ability to reproduce analog conditions. So the whole deal is with this, we programmed this thing, and it's reading the value from the resistor as the power goes through. But we still don't know what the value is because even though the circuit's all set up correctly and the LED might be going up or down or whatever, we don't know what the Arduino's thinking. There are things built into the Arduino programming language that allow us to have the Arduino tell us what it is thinking, what values it has stored in memory, stuff like that, like whether or not it's entering a function that we wrote. And these are serial print commands. Serial print is something entirely separate from the components that you can hook up to an Arduino. Basically, serial print sends a value out through the USB to the computer that it's hooked up to and is visible on your monitor. So yeah, serial print allows the user to view the data the Arduino is processing. It is an incredibly useful tool. It allows the user to get a direct look inside the Arduino and can be quite helpful in normal troubleshooting. So this is basically a debugging tool for Arduino. It allows us to take a look at some of the values held in memory so we can look at it and be like, wow, okay, so the LDR really isn't giving us appropriate values. Maybe the LDR is broken. Or, oh, wow, you know, we're getting input sent to the Arduino that the button's on even when it's not. Maybe we had the value flipped or something like that. So it allows you to view memory states in the Arduino and stuff that it's doing so that you can more easily troubleshoot your circuits. Now I say like, oh, I can view stuff in memory and, you know, I can tell you what, you know, stuff you're entering and blah, 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 blah. That's stuff that we set up entirely as programmers. So when I say these things, I'm just throwing out suggestions. There's other stuff you can do with the serial print, and it's really only limited by how you code the serial print in. But you'll see what I mean in a moment. Serial print has a couple of lines available to it. You've got serial print and serial print line. That's what the LN is short for. So serial print will print out the given variable, like, and you see how you got variable in parentheses there? That would be like a variable name. And this particular line would print out the given variable without a new line at the end. So you could put serial print LED pin, and each time serial print is called, it will print out LED pin to the serial monitor. Now, serial print line variable will also print out LED pin, but it'll put a little new line at the end. So instead of just being like serial print would do, It would instead be like, which is much easier to read, especially when it's going to be moving that fast, because depending upon how your program is written, it'll be much faster than that. Like it'll be so fast that it'll just start flying down, and then you'll get a scroll bar that progressively gets smaller and smaller and smaller and smaller and smaller and smaller. And that's really the only way you can tell how fast it's moving. So serial print line can be much more helpful for that kind of stuff. And you can put in manual delays so that you can read the value. And there's that. And then so now we're going to mess around with digital read. So now that we've talked about the serial monitor and all that good stuff, we're going to mess around with digital read so that we can get a proper input-output circuit set up. So let's go back to our breadboard. I'm going to rotate it, as always, so that it's sitting upright. And components, I'm going to bring in an LED. I'm going to bring in a resistor. I'm going to bring in a button. Just go ahead and do a search for button. We'll pull out the smaller push button, and I'm going to look for Arduino. I'm going to pull out another Arduino Uno R3. So these are our 4 components. We've got push button, resistor, LED, Arduino. So now let's take a look at how we're going to set this up. Okay, I don't know what kind of resistor that is. 110, I think it's 110 ohms. Or no, 221. 220? 22. That's only 22 ohms? That can't be right. Unless that's orange, 33 ohms. Oh, that's 330. Good Lord. Okay. What is this one then? 103. I believe that is a 10,000 ohm resistor. Okay, so let's go ahead and copy paste this resistor. So we have 2 of them. We're going to set one of them to 330 ohms, and we're going to set one of them to 10,000 ohms. So now we got a 330 ohm and a 10,000 ohm resistor. And that's just an educated guess based on whatever color this is. That looks like that's orange, so I believe that's a 10,000 ohm resistor. So this is going to be, these are going to be the components that we have for our circuit. So let's go ahead and get those hooked up. What do we set the resistor to? One of them is going to be 330 ohms, and one of them is going to be 10,000 ohms. So one 330, one 10,000. Oh, there we go. Okay, that works. And I'm going to set up my push button so it's straddling this middle break and all of the horizontal rails. So as you can see right here, we've got one terminal on F20, one terminal on F23 or F22, and then we got one terminal on E20 and one terminal on E22. So like so, it's straddling that break. Once we've done that, we're going to take our 10,000 ohm resistor and we're going to hook it up on the terminal, the top right terminal on the push button. And that's going to go to the plus rail. It's going to go to the plus rail, I believe. Yeah, it's going to go to the plus rail. Oh no, it's going to go to the minus rail. I think that's what that arrow was meant to be. So we're going to move over to the minus rail. So that 10,000 ohm resistor is going to go onto the minus rail. Then we're going to hook up an LED like so. You want to make sure that the anode is the one that's going to get hooked up to the power on the Arduino. So we're going to hook up the cathode, or the straight leg, to the minus rail. So both resistors are plugged into the ground rail, the minus rail, on our circuit. We want to be absolutely sure of that because that is how we are going to control the power on our LED. So far so good, right? Now we're going to hook this lower right terminal on the push button to the hot rail, the power rail. We're going to turn that blue. And then we're going to hook up the upper left terminal on the push button. We're going to hook that up to pin 8 on the Arduino. That frees up pin 9, which we're going to, whoops. Pin 9 is going to be hooked up to the LED. Now we're going to make that turquoise. No, we're going to make that brown. We're going to make this one, we're going to make this one orange. No, we're going to make it purple, I guess. And then we're going to hook up the minus rail to the ground on the Arduino. Finally, once we've done all of that, we're going to hook up 5 volt to the plus rail. Red and black. So this should be our circuit. The push button is a little weird because the lower left terminal is not actually connected to anything. That's because basically a push button bridges things from the left terminal to the right terminal. Left terminals to the right terminals. And you really only need one input in order for a push button to work. You can have 2 inputs hooked up to it, so it can control 2 inputs to 2 outputs. But we want to make sure, or yeah, well, sorry, it's the other way. It's from here over to here. We want to make sure that we're only controlling one output. This one's just providing power to the LED. Technically speaking, it's actually on an entirely separate circuit from the push button. Why would we have that hooked up? Like, what good would that do us? Anybody? Well, okay, we can just tell the Arduino to turn on the light whenever we get an input from the button. We're going to do that, but not immediately. First, we want to use the serial monitor in order to see the result of the push button. So we can, if we simulate it, we can click the button to our heart's content, but it's not going to do anything yet. So let's go ahead and click Stop Simulation, and we'll bring up our code editor because we're actually going to use some code and the serial monitor that is built into this to get an idea for how the Arduino works with input. And this is not, okay. So here's what we're going to do. We're going to do a slight modification of the code that we've got listed here. So of course, we need our void setup and our void loop, like we always do. And in our void setup, we're going to set up not only the pin to be an output, or excuse me, an input pin, we're going to set up our serial monitor. So here we go. The input pin is going to be as simple as going pin mode 8 inputs. Why pin mode 8, you might ask? Well, because pin 8 is the one that's plugged into the pin, or excuse me, the button. So pin mode 8 is going to be inputs. And then this part is important for the serial monitor. What this does is this sets the rate at which the Arduino is going to be sending data to our computer, our virtual computer in this case. In real life, if we had like a physical Arduino, it would be the rate at which the Arduino sends information to the computer. And then that in turn, you can change that on the computer to see how it's going to be affected by the, you set it up to something that the Arduino can read. So that's our void setup in full so far. We set pin mode 8 to be an input pin, and we set up our serial monitor to get ready to send data. Now we need to actually read the value from pin 8 and print it out on the serial monitor. So that's done down here in void loop. So you know how we had digital write all the time for our LEDs, turning them on and off? Well, it just so happens that there's a digital read. And in fact, what we're going to do is we're going to take the value of digital read each time void loop loops, and we are going to place that value into a variable button. Do we need to do this? Strictly speaking, no. But we are going to do this in order to get a little bit more familiar with how we can pass values and use them in the Arduino and stuff like that. So that's what we're going to do. So what we're doing is we're taking in the value from pin 8 and we're placing it into a variable called button. Then we're going to misspell serial, and then we're going to correct it. And we're going to have the serial monitor report the status of button. And we make it a print line, so it'll print it vertically. So we're not just getting this whole long line of just like instead it's going to be like without the extra ones and zeros on each line. Furious typing, furious clicking. Anyway, that's going to be our program for this Arduino right now. I know it's not terribly exciting, but what we're actually doing right now is we're taking input in from a button. We're taking electrical information in on a pin, and we're making sure the Arduino registers that information. The only thing we're doing with it is we're having the Arduino tell us what the state of that button is, as it stands right now. But with this right here, you could do whatever you want with that. You could ask, hey, is the button pressed? Well, then go ahead and do a thing, like send the value out on the LED pin and then turn the thing off or whatever. You know, you can mess around with that later on to have the Arduino do stuff that you want it to do. For now, we want to make sure that we're registering that there is input coming in. So let me go ahead and prettify this a little bit. Boop, boop. We'll have a little bit of space here. I'm going to copy and paste it and put it in here. And just so you guys have it in chat, or at home, there it is in chat so you can compare your code to it. So now, assuming everything's gone correctly, I'm going to go ahead and click Upload and Run. It is now currently running. I can go to the serial monitor and I can see a whole bunch of zeros, but when I press the button, bam, those zeros turn into ones. I let go of the button, they turn back into zeros. In fact, we can tap the button and see the ones and zeros just sort of fluctuate. Over here on the right-hand side in the corner, the bottom corner. Look at it go. Look at it go. Yeah. So it's obviously not a completely 100% lag-free experience, but it's kind of cool to see that it's doing its job. So we can verify by the fact that we're getting ones out whenever we press the button, that the button is in fact working and the Arduino is properly registering the state of the button. Raise your hand if you've got the same thing going on. Awesome. So we got a couple of hands. Excellent. Also, welcome back, Vincent. Raise your hand if it's not performing exactly as you expected it to. And that's okay too if it's not. Okay. Well, for the most part, that's everybody. Now, we've taken input. Excellent. We can modify that input. Even more excellent. Or modify that code to do something with the input. So that's what we're going to go ahead and do. One line down so far. What we've done is we've set up pin 9 to be an output pin. Now, I believe we can do this. If we can't do this, well, it's just another instance of me being wrong. But let's test it out. So what do you think I'm doing there? On this line right here that I so helpfully created an arrow with, and now I want to highlight. What do you think's happening there? Yeah, basically. Okay, so button is the value that stores the result from digital read, right? Or the variable that stores the value from digital read. Now, from watching the serial.print line, we see that digital read gives us either a 1 or a 0. Digital write asks for a pin and a high or a low value, right? If it's high, the button is on, or it's writing power out. If it's low, there's no power being sent out. High and low are simply just synonyms for 1 and 0. So if we get if the button is pressed and power is being sent into pin 8, digital read is going to be 1. It's going to put 1 into the button variable. Then when it gets down to digital write, it's going to say digital write is going to receive the value of pin 9, and it's going to receive the value of button. In this case, it's going to be a 1. So it's going to send power out through pin 9. And this is going to repeat. So maybe it's still on. We're still pressing down the button. It's going to get the on value again, and that's fine, until we stop pressing the button. As soon as that happens, when we get to this line of the code again, digital read is going to start up. It's going to send a value of 0 to button. Print line is going to give us a value of 0 on the button. And then when we get to digital write, it's going to say, hey, 9, 0. So it's going to turn the LED off. So let's go ahead and give that a try. And I'm going to put this into the chat box as well. So this is V2 of our input program. Bam. Let's delete these extraneous lines. Now let's upload and run it. Successfully compiled. We're getting zeros, we're getting zeros. Let's press the button, and the LED is on for as long as we hold the button down. Pretty cool, right? You could do this in real life as well. If you had the same setup, you'd be able to press a button and have an LED light up. Wow. But hey, like that's the first step to creating, controllers, and as in like, Xbox controllers and doorbells, kind of. Although you could use an Arduino for a doorbell, but that seems a little bit excessive. Walkie-talkies, anything that uses a button that sets it up so that you can do something else. You could have a button in your house. You just press the button, and you could have your Arduino send out an email to somebody and be like, hey, I sent you this email at such and such a time, and it'll pull the time and date, and it's like, and you should call me or something. That seems kind of ridiculous to have a push button for it, because you could always just text them, but it's something that you could theoretically do in case you ran into a situation where you weren't able to do anything else. But yeah, so through the Arduino, we've set up a button. Now, we could have done this entirely without the Arduino. We could have actually set up a circuit with a button that causes the LED to light up, and we would never have needed to have the Arduino hooked up in this entire process. It's true. However, the Arduino does allow us to do more complex starting and stopping conditions. You could have a button, and you could have an LDR, and then as soon as the LDR reaches a certain value, and the button is pressed, then the LED turns on. But if the LDR is too high or too low, then the LED won't turn on, even if the button's pressed. If the button's not pressed, the LDR could be giving you the correct value, and the button or the LED will not turn on. That kind of thing. So it's entirely possible to do that, but this is just a simple example. So there you go. Now we've messed around with digital inputs. If we had physical Arduinos, we could mess around with analog inputs. And we've converted those inputs into an output. Yeah, we could do. There's a way we could expand upon our program. That would allow us to do more complex things. The way I have it right now is a little bit more compact, and in fact, we could compact it even more, believe it or not. If we were just looking to send values out on digital write, we could say so if we were to run this would actually run like a dream. And notice how it runs exactly the same as it did before, because we just eliminated the middleman. We got rid of that variable that keeps track of the stated digital read, and we just dumped it out directly into digital write. So the result from digital read just gets dumped into digital write so that we free up some memory on the Arduino. Sometimes you want to do that. Sometimes you want to make it more readable, so it's not always the best solution, but it really depends upon your preferences and how, easily you can understand what exactly it is you're doing at a certain point, which can also be where comments come in. Boom, comment. That kind of stuff. Anyway, now we could actually expand upon this a little bit more, and we could take and you don't have to type all this stuff out. I just want to show you guys another quick concept. Or alternatively, these are, if-then statements. Good Lord, there we go. If the stuff in the parentheses is true, then we run the code inside of the if statement. If the stuff in the parentheses is not true, it'll continue to check other if statements, but it'll skip this entirely. If we have a string of if statements and one else statement at the end, if none of the if statements that came before it are true, then the else statement will run. The else statement only runs, though, if none of the if statements that came before it run. I'll get into more detail on that in our next class, but I just wanted to sort of touch on that and introduce this really quickly, just so you guys could take a look at it, see what you could do with that, because you could put a bunch of complex code inside of this if button equals 1, or you could have it if digital read, whatever. I can spend more time explaining that kind of stuff. But anyway, I'm going to go ahead and I'm going to ask the poll questions. We're gonna turn it to poll question, then question and answer time, and then you know the drill. If you guys have any questions, I'll be here. Otherwise, you're more than welcome to head out and have a wonderful couple of days, and we'll see you on Wednesday. So here we go. First poll question incoming.